This video is on the chi-squared test for independence. So first thing we're just going to quickly talk about is hypothesis testing. So in stats, a hypothesis is a statement about the unknown parameters or features of a dataset. Our initial hypothesis is called the null hypothesis, which we write H and a little o. The alternate hypothesis, a H1, will be accepted if HO is rejected. So some examples of null and alternate hypothesis. So a population mean is 20 centimetres or more than 20 centimetres. So the null hypothesis would be that the mean is 20 centimetres, and then the alternate would be that the mean is more than 20 centimetres. The choice of a game is independent of gender. So our null hypothesis would be preferred game is independent of gender. Alternate preferred game is not independent of gender. Now, if you're talking about this independent, please always write it this way, especially within the IB. They don't like it if you try and use words like relationship. So always just use that one is independent of the other, and then the alternate one is not independent of the other. So in the chi-squared test for independence, it shows whether two data sets are independent of each other. It can be performed at various significance levels. The degrees of freedom, often df or v, is the number of values which are free to vary for a contingency table. The degrees of freedom equals the rows minus 1 multiplied by the number of columns minus 1. There are two ways to know whether you will accept or reject the null hypothesis. This will depend on information given. So we can compare the chi-squared statistic with the critical value. If the chi-squared is less than the critical value, we accept the null hypothesis. If the chi-squared is greater than the critical value, then we reject the null hypothesis. You can also compare the p-value and significance level. Significance level will be given as a percentage, like 1%, 5%, or 10%. If p-value is greater than the significance level, then we accept the null hypothesis. If it is less than the significance level, then we reject. Just to note here that the critical value or the significance level will be given to you in the exam. So you just look at which one you've been given to then work out if you need the chi-squared or the p-value to evaluate it. Sometimes you may be given both. That's fine, you just pick one. If you're doing it without a calculator, this is how you work out the chi-squared. This will only come into play if you decide to do statistics for your Math IA, then you would be expected to do it by hand. In exams, you would just have to do it on your calculator. These are the steps for chi-squared on a calculator, so there is a number of one. So and this is for the TI Inspire. So menu, your number 7 matrix, then you go to number 1 create, number 1 matrix, and enter the number of rows and columns. You put your table into the matrix, then go to the end of the table, don't press enter, and you go control, there, decide on a name for your matrix, and then press enter. So you are storing your matrix as a variable in your calculator. You then go to menu, statistics, stat test, the chi-squared two-way test, enter whatever you called your matrix just before, then press enter, and it will come up with a list of all your information, including the chi-squared value and the p-value. So let's have a look at one here. So 80 people were asked for their favourite genre of music, pop, classical, folk or jazz. The results were in that table. A chi-squared test was carried out at 1% significance level. The critical value is 11.345. First of all, we're going to write down the null and alternate hypothesis, which I have already done. So our null will be that favourite music genre is independent of gender. The alternate, favourite music genre is not independent of gender. B, show that the expected value for a female liking pop is 21. So to do this, what we need to do is we want female and pop. So you take the total for the female, which is 42. Then you multiply that by the total of the pop, which is 40. And divide that by the total of everybody, which is 80. You do that and you'll get 21. C, write down the number of degrees of freedom. So degrees of freedom, remember, is the number of rows, which is 2 because you've got male and female, minus 1, multiplied by the number of columns, which is 4, minus 1. So we'd end up with 1 times 3, which equals 3. D, find the chi-squared test statistic and the p-value. So follow those steps from before in your calculator and you'll find that the chi-squared is equal to 1.62 and the p-value is equal to 0.654. Then E, state whether the null hypothesis is accepted or not. So we can use the chi-squared or p-value because in the question we were given a significance level of 1% and a critical value of 11.35. So if you're going to use a chi-squared, we know that 1.62 is obviously less than the critical value of 11.345, or we can see that the p-value 0.654 is greater than 1%, which is 0.01. So you can look at either of those and therefore we will accept the null hypothesis. And that is the chi-squared.